Welcome back to the third episode where we're going to be training the main model that we're going to be using. And in this third episode, it is broken into four sections. The first one is creating the needed dataset, then creating the training Python file and running it. Then we register the model, then we make prediction using the registered model. So that is what we're going to be covering in this episode. So let's move into the code quickly. So what we need to do is we need to have a file to create the dataset that we need from the raw dataset to make it processed. So now we're trying to do our work in a more modular way that is the best practice or one of the best practices in organizing your code and your file for a standard machine learning project. So there might be other ways that is more advanced to do this, but this will cover at least a starting point. It covers the fundamentals. So to do that, I'll go into the data, and inside the data, we've created this Python file called make_dataset while we were creating our file using the SH in episode 1. If you haven't seen the episode 1, you can see it in the playlist and link back to it, and you can watch how we downloaded our dataset and how we set things up to this point. The environment is activated, and we can continue our work. So if you want to see how everything is done, you can go back to the episode 1, so I don't have to repeat myself in this third episode. So we dive in directly. So we need to have our make dataset, we need to make it work. So we need to take our code from Notebook and ensure that we're able to set them up to load our data in the make dataset. So we are going to reach off our Notebook and trying to modularize them to make them work. So we have the import, OS, and pandas. This is PD because all we need is to load the dataset. So we only need these two. Then we define a function and we can call it df and we can call it load, let's say raw. The data is movie length, so let's call it movie length and have that function this way. And what we need in the function is just the same thing we did in our Notebook. So we just copy this, which is the item path. Then we'll bring it to the dataset and just say item, and I will do escape. I don't want the suggestions. So I have the item path. So then within the item path, the next thing is to load the item. So everything is still done within that function. So the same thing we did, you can see what we did here. So we just copy and say make dataset. Okay, so that is done. Just what we have in our Notebook, what we had in our Notebook is the same thing I'm copying here. And what we want to return in the end will be to return our items. That is all we need in the end. We want to return the items. So we just say return items. I'll say return items. So let me close this to make things clear. So we say return items. That is what we need here. So we have the item path, and we use the item path to load the item, and we can return the items. So that is what we need to do here. Then the next thing will be to preprocess the data. So it's always good to have different functions to do the preprocessing. And in our case, we are only using just one step in the preprocessing, like we did in the train.ipmb in the Notebook. So the only thing we did with respect to preprocessing is the drop NA. So we can just copy that. But this time around, since the item that was returned is a data frame, we're going to just call this df, and what we're applying to it is just a df and df, just for clarity. That's all we are doing. And we return the df. So that is what we're doing in preprocessing. So we could have done everything directly in the load raw movie less data, but it's just good that we have that separate, because sometimes you may have some data set that you have to do multiple steps in the preprocessing phase. But because this data is already like clean, it has been cleaned already, so we don't really have so much to deal with respect to pre-processing. So we return the df, and the next thing we do here now is to now save whatever we've processed in the end. So we can say save processed and data frame. So the save process will take the data frame. So the clean data frame will be passed into save processed, and it should handle the saving process, the saving. So I will just copy this easily directly. So within our data, we have raw. Then we create like a process directory. So if the directory exists, we say true. That is, if we have process created, in this case, we have the process created already, it will just replace it. It will just have it that way and push the file into processed. So it will not create a new one. Then we just say df to CSV interaction.csv. So if it is very heavy, it is a very heavy file, it is advisable to have it as a packet file. But in this case, it is not a very big data frame, so we are good to have it as CSV. Then everything will then be brought together in our main parts. So yeah, so pre-process. Okay. So, and the reason we really use this is it makes it interesting. So when we run our code, it makes it easy for us to use our whatever we've written here as a library, where we can even call this function in another file. So it makes it very interesting. So it's one of the best practices, but there might be other better way to do this. So we've been able to have a function. So we load the raw movie length, we have the process preprocess, and we have the save process function that we call, that we then save everything. So we need to run our data. We need to run our code now and see how that works. Like I suggested the other time, I suggest that we just run our data like as a module. But here, since I'm not really using anything that is from like configure MLflow, as stated in the episode 2, I will just run the make_dataset.py directly from the root without running it as a model. I'll just say this make_dataset and I'll run it. And that returned an error. And I want to see why that error is coming up for me. It is in the way I use the directory. So the best way for me to do this could have been doing it using this form where I have the path separately instead of like linking to the path. So I can do it this way where I have the data, I pass it as a parameter into paths join separately. So we have the data, the raw, the ML100K, and the u.item. So I'm going to clear this and I'll run the code again and see if it works. Okay, now it works. So we have everything working. So error is part of the process. So the main thing is being able to spot it quickly. So we have process data now saved and processed. So we can move to the next thing. Now we need to create all we need in our training model file. So we come back. This is the data, the code that is handling the data from the source. Now we come into models and we come into train model where we're going to be doing having our model. So for the model, it is still moving from the notebook to, let me move this closer, still moving from the notebook to a standard Python file, then making some changes that make the whole process reproducible. So we have the same set of libraries, but we now have more. So here we have the MLflow.python, and what this is doing is that it is helping us to package our class into a model where it can easily call it, can easily store it, and handle all those processes. Then the next thing we need is our utils. Remember what we did before, like we had it here. So here now we have more stuff. We have the MLflow and every of these things that we didn't have in the notebook. So move to the next thing, which is to handle like our class, just like what we had before. So we can, for clarity, I'll copy this, what we have before, and adjust it to make it clear. So this is what we had. This was the class that we had. But for us to be able to have this in an MLflow model form that MLflow can easily serve, we need to pass into the movie recommender model, we need to pass the MLflow python. So we need to pass that. You can see, glad my auto suggests cut that. So this is one of the things that we need to do. So now that this is done, instead of having this as items and similarity matrix, here, because we have the items generated already, we have the items similarity matrix, we are not just creating them here. But what we are doing now is that we want our model to be all encompassing, we want it to be compact. So what we're doing now is, instead of passing item and similarity matrix, what we're going to be doing is we call it context. We call it context. And what we do within context is, it is within this object that we're going to be loading the item. Within this object, we're going to be loading the item. So there would have been the item lookup and similarity matrix, but we're going to be loading it within this context. So to do that, we just say pd.readCSV, pd.readCSV. Then this similarity matrix would have been saved as a joblib package. So we have this. So to make it clear, I'll just move it from here. So it has been saved using joblib already. So we can load it. So you can see, so we can have it as context.artifact. So this item lookup, initially, if you remember in our MLflow, we had our requirement.txt as the artifact of our model. So here we are now having our item lookup and the similarity matrix as the artifact. So this is how we get our item lookup. This is how we get our similarity matrix. So this is the main change, the central change that we need to make to have our code work perfectly. So if you've not seen the episode where we did this, that would be the episode 1. You can watch it and see we went through this code and explained everything. So the only thing I'm just adjusting here is I passed in MLflow.python model. I passed it into the movie recommender class definition. Then within the constructor, I am changing the way I call the item lookup and similarity matrix. Here, I am loading it as an artifact, and I am also loading the similarity matrix as an artifact. So that's all. And we are doing this because we want it to work within MLflow. We want MLflow to be able to understand what this model is. If you are using a pre-built model, like if you are using random forest or other stuff, you don't need to do it this way. But this, we have to do it this way because we are building it from scratch. It's more like a custom movie recommender model. So that is the way it works. So that is that we need to do there. It's just the same thing. So the next thing we need to do then is to have our load items. So to load our items, we just define a function also to load it, and we'll return it. So we're having it in functions to make our code readable and also to be able to catch any error easily from wherever the error might be. So that is what we are having there. So in the load items, and the next thing will then be the build similarity matrix. So what we did here, the same exact thing that we did to build the similarity matrix. So what we have here, we're going to be putting it, building it into a function, having it in a function. So that is all that is changing. So we have this in form of a function. So the same thing we had here, I'll just copy to compare. So you see the mass feature here, now we are passing it as part of the parameter of this function. Then we have the items also passing it as parameter of this function. So we load the item, use the item in the build similarity, the mass feature, and every other thing looks the same. So that's just it. That's all we have to do over there. Now we move to our main. So df main. So the first thing we need to do is we need to configure MLflow. We need to have this configure MLflow. Configure MLflow. We need to have that as a function that we'll call right here. Then we define the experiment name. So I have all this written here. So I'm going to bring them in chunk and explain it line by line. So this is the experiment name. I'm not going to call it test. So I'm just going to say movie content-based, movie-less content-based. So we have the experiment name. We set experiment name. I explained this when we're doing the dummy model that we did in trend baseline. So experiment name is just the name of the experiment. So we say MLflow set experiment name. The items, we use the load.items function. So whenever this function is called, it will load this data frame by itself. Then the next thing will be these build similarity items. So the build similarity items will return two things. It will return the TF IDF, which is the vectorizer, and the similarity matrix. So what we really care about is the similarity matrix. So we have the TF IDF similarity matrix. We are getting that from the build item similarity index function. Then when that is done, a directory called models will be made. The directory called models will be made. And if the directory exists already, it will just have it that way. It won't change anything. It just pass whatever I want to send into the model into it. Then within these models, we dump our similarity matrix using joblib. And we also save our item lookup as items.csv. Item.csv, then we save our item lookup also into models. So when we run that, we're going to see how it works. So after doing that, the next thing would then be to undo the MLflow part. So in the MLflow part, the first thing we do is using with MLflow. And with MLflow is where we say, okay, start the run, and we can give it any version. You can call it version 1, version 2, as you want. And if you don't add any run name, it's going to generate a run name for you. Then you log the parameter. So the parameter we are logging here now, the model type is a content-based movie recommender. So you can call it content-based or anything you want. The mass feature, we want to log that too, which is TF-IDF mass feature, which is 5,000. Then we also have the metrics. And the metrics is the number of items that we have. The number of items that we have is also the metrics that we are logging. That is, how many movies did we build recommendations for? The next chunk is going to be our artifact. So initially we had a context artifact. Then for our artifact also, we want to save this similarity matrix as an artifact. We want to have the item lookup as an artifact, because this will really help when you want to use the model to predict. So we want to save them as an artifact. So that would have been stored in the model folder over here. It should have been stored in the model folder. So we get from the model folder and store it as an artifact. So it's going to be saved as part of the model. Then another optional thing that we add to our model is the input and output example. So that when someone goes into your MLflow directly, let's say you're collaborating, they know what kind of input the model receives. And the model can also validate by itself if the input follows the right structure or it doesn't follow the right structure. So you can see we have the input example. The input example is a data frame, just like what we did in the notebook. So it is a data frame and it returns a list of lists here. So this is the input example, which is the data frame containing the title and the top key as the columns. Then the output example is a list of lists. That is a list containing the list of the recommendations per movie you have in the data frame. So this is an example that you have. Then to make that work, we're going to be using the signature, which is the infer signature that we imported initially. So this that we have here, this infer signature. So that's what we're going to be using. Then we just pass in the input and output example. To then make everything work together, we need to log this whole package that we have here. We need to then log everything together as a model. So over here, we're logging parameter, model type, we log parameter, we log metrics, but we haven't logged a model itself. So to log the model, we can then use this chunk to log the model and MLflow.python.log model. So the Python or Python function is what has been helping us. So the name, you just call it model. You can call it any name. Then this is the Python model, which is the movie recommender class that we built. Then the artifact, we pass the artifact. The input example, we have the input example. Then we have the signature, which is this, which is the input output. Then the last thing we need to do is the run ID. We want to just see, this is also optional. We want to see what the run ID is at the end of the run. So this is basically all we need to do. And to make this run, because we built everything into functions and we have the main function, we are going to use the main to run the same thing. So we have it run this way. So we need to run it now. And to run it, we need to run it as a module because we have the config flow in it. So we need to run it as a module. So Python M, SRC, models, train model. So I'm going to run it and hopefully we don't come across any error. Okay, so it is missing a position argument called context. Oh, I see. So what is wrong here is that we are using this constructor, we're still using the normal constructor instead of using changing into like a Python function that can load the context for us. So I'm just going to change this initialization to load context. So I think that's what I need to change. So with this, it should be able to load the context as defined. So be able to load the context as defined whenever the model runs. So we have it as a method also, so we can load the context as defined. Then we can run it again and see what happens. Nice. So you can see logged to this run ID. So it means things worked perfectly. So to confirm, we can go back to our MLflow to check. So if I go back to MLflow home, you can see now we have movie lens context based. So which means our model is logging correctly. So we have movie lens content based. So there was a first version that we did, which returned into error. So then we ran it again. It was the same run name, but this is what we care about. So for me, I think I would delete this one to avoid any conflict. So we have it this way. So perfect. So if we go into the V1, we can see everything we logged. Our number of items, we have 1682. Our mass feature was 5,000. And we have the run ID. We also have it in our terminal. And model metrics that we logged. It just does the normal items. That is the metrics. And we have the artifact. And these are the artifacts that we logged. You can see the item lookup and the similarity matrix. So everything is working fine. So now that all is working fine, before our model could be used to predict anything, we need to have it work registered. We need to have it registered before we can use it. Then to register it, we need to go to our inference folder. So before we run anything other predicts, we need to create a register model.py. So I'm just saying register model.py. Register model.py, and we're going to go through the register model.py one by one. So in the register model.py, we import the required library that we need. We need the MLflow and the utils. So because the register model needs to also get the tracking URI from the configure MLflow. So let me clean all this to make things clear. Okay, let me clean all this. So it needs it. So to register the model, our plan is within a specific experiment, we want to register the latest run. So to do that, we need to be able to get that latest run, the ID of that latest run. So to grab the ID of that latest run, we'll do it with this function. And how this function works is that we need to get what experiment should be used. So client.getExperiment, the client is the input. So the client.getExperiment by name. So we have the name movie lens content based. Like we saved it in the model, so we can see it in the model. Let me show. So it's called movie lens content based. That is the name of the experiment. And we come back to the code, And the code said if experiment is none, that is, if there's an experiment, it should return an error. Error moving length not found. Training script must be created. So then experiment ID equals the experiment.experiment ID. So if there's an experiment, then it will get an experiment ID if there's an experiment. But if there's no experiment, then we can't register anything because the experiment does not exist. But if the experiment exists, then to grab the experiment ID. Now it will then go assign it into runs. So the client is going to use the search method in the client object. Then we have the experiment ID. Then the experiment ID will be used to order the runs that we have in our model. So we only want to pull out one out of the experiment. So start time and description. That is, and descending order, I mean. So the order by is going to sort the model in descending order. So then the first one is going to be picked. That's what we care about. We want to get the latest run. So this is the part that is doing that. So for that latest run, if there are no runs, it's going to say no runs found, because when I create an experiment that there's no successful run, no runs found is going to tell me to ensure that this train model.py log the run. So which is the train model, what we run here that created it, which is our modeling process, the main model. Then we grab the latest run. The latest run is simply the first thing within this run. So that is runs 0, which is the first one. Then it will be first one. It is also the only one because our mass result is just one. Get one run out of everything. Then the run ID then is equal to latest run.info.run ID. So we need to grab the run ID of the latest, then print latest run ID detected. So in essence, all this is helping us to get the latest run. So that is what this function is doing. So when we get the latest run, we can then use that to register the model. So I'll run through the main function that we'll be using. So within the main function, I'll go chunk by chunk to make it clear. So the first thing we are doing here is going to be the registering process. So where we configure MLflow, that is the first thing. The client is the MLflow client. We imported it right here because we need it while registering the model. So then the model name, we call it movie recommender. That is the final model name that we're going to be registering. Then the run ID, we grab it from the latest run, the function we created, and we say print registering model from run ID this. Now that we have that, we then need to know the source where the model was registered from. So we need like a link. So the link is going to be like the runs, which contains the run ID and also the model. So we need to grab that. So register model version from, then we'll get the source where it is running from. So the other part that we are doing is just ensuring that the registered model exists, because it is very important that we have that. So we need to ensure that the registered model exists. That is what the next part is doing. So we use this. I will just say ensure that the registered model exists. So what it's going to do is going to do a try and accept, so to be able to catch the error in case there's any error. So when we run it, it's going to get a registered model, then say registered model already exists. If the model is existing already in the model registry, and if the model is not existing, it's going to say model does not exist, creating it. So it's going to create a new model from scratch. So it's going to create a new model, not creating a new model in the experiment, but creating a new registered model. So to pick from the experiment and register a new model. All right, so that will move into the next thing. And for the third part, the third chunk, what we're doing here is that we just create like the model version. We want to get the MV, the model version. So we say client.create model version. Then the name is the model name, which we have right here, movie recommender. And the source is the source that was created here. So whatever source we have, which is just run ID / model. So run/run ID / model. Then the run ID is the run ID that we have. Then print created model version. So we're able to print the model version that we have. Now the fourth chunk is about setting alias. So this chunk is optional. It's just to set alias. So it is optional. So I'll just say set alias, optional. I'll say it is optional to make it easy to comprehend. Setting this is optional. So the alias, I call it production. So whatever you want to label it. I prefer to do this because it makes it clear that the model is the model I'm using in production. So you have client.setRegisterModel alias. Then we have the model name, the alias that we have, then the version that we've collected, the MV version that we have over here, which is the MV version here. So we're able to save that. So set alias, the alias, model name, and the version is MV version. And the last part, which is the last chunk, is going to be the, I think I'll call this 4. I'll call this 4. And the last chunk in the model registry is to show all versions. So showing all version is we print the register models. So we just print the model name, then some information that we need, which is to get the registered model and using the model name. So to print the information about the model and the version and all other things that are important. So here we are just seeing stuff. This is not where the main thing is happening. So it is just showing us the output of the process. And to run that, we just do the usual, which is if name.main, and we run the main on that. So sometimes you can decide to run it this way instead of having the defining the function as main function. You can just have this, and you can run the code that way. It is also going to work, but I'm not doing it that way. So we have this way, and we can try to register our model and see if it works or not. Okay, so okay, and I can't run it directly. Also, I will need to run it as a module. So, and we run it as a module because of the config file, the MLflow config. So we have the Python module, then src inference register model. So we're just going into the directory. Go to the source, inference, and register model, and let's see if it works. Okay, I think it works. So we have the created model version 1, then the movie recommender version 1, the alias is production. So you can see here, it says registered model, movie recommender does not exist, creating it. So it created it, so it created model version 1. So our model is registered now. We can verify in our MLflow if our model is in our model registry, if everything is fine. So I'll come to models. So this is the registered model, and you can see our model is well registered. Alias production and version is version 1. So yeah, that is what it takes to register the model. And the last phase is to make predictions using the registered model. So that is where we're going to be setting this predict.py file. That's where we're going to be setting it up. In the same way, we need the same set of libraries, but this then our utils, we import that also, which is our configure MLflow. So we need to define the name of the model name, and the model version. The model name, and because you could have registered multiple versions, so it is important that you define the model name and the model version. We need it to be able to use the model. So in this case, it's going to be version 1 because we have it. Yes, model version is version 1. So it is model version 1. And all we just need to do is to define our main function and do the usual for everything we want to do. So long as it relates to MLflow, we need to configure MLflow. Now we need to set what should the model URI be, because the model URI is what the prediction we point to before any prediction can be made. So to do that, we need our model URI, and model URI is just model name and version. That's what we make up the URI. So you can see this is the URI, which is the okay. I need to tabulate it. Something is wrong. Okay. All right. So just for clarity, now we have the model URI, which is models using the string function, the f string. Then we have the models combined with the model name and the model version. So the final URI will look like something this way. So you're going to have just to show. So we have something like this. We have the model recommender, then /1, something of that nature. So we're going to have it, model recommender. No, we don't need this. So we're going to have something like this finally as the model URI. So it's going to be in string. So this is the final, this is what the final model URI looks like, for example. So we have that as a model URI. Then to be able to call the model, we need to use the pyfunc model. Then we say the model, which is the mlflow.pyfunc.load model, and we pass in the model URI. So with this now, we have the model, and we can then run the prediction. But just for the sake of status, to know what is happening in our system, we will add the print function that's a loaded model just for us to know that the model was loaded successfully. So what we want to run with the model is create a data frame and see if we get the output from the data frame. So hopefully that will work. So we can use the same data frame that we had in our train.ipmb that we used to test. So we can have the same data frame. So I'll just say input df, I'll just copy this and use that. So we can have the same thing that we used. So what we just do here is we just say prediction, because a prediction equals to model.predict into df. But when the output is coming, we need to be able to want to have it in a clear form in our terminal. So we're going to use this for loop. We loop through the output so that we can have the recommendation for each title. So instead of having it in this form that we had, instead of having it here, where we can't really link it to, which is Toy Story, which one is the other one. So Philadelphia Story is the first one, Toy Story is the other one. So to be able to segment things clearly, that is why we're going to be looping through. So I'm not working here anymore. So we're going to be looping through the results. So it's just to say, have a for loop that loops through the results. So we have the for loop loops through the query, which is part of the model. So it will loop through the query, whatever the query is, then and the recommendation. Then it's going to zip them together. It's got taking them from this zip. So it's looking at them in terms of a key value pair. In a way, so it's taking like the title, which is the query, then the predictions, which are the list that is coming out. So it's zipping them together to treat them as if it is a key value pair. Then it can be able to print the recommendation for the query, which is going to be this title. So to show the title, then look through the recommendation and also show the recommendation. To run that, we use the regular if underscore the name equals main. So I believe this will work now if we run our prediction. So to run our prediction, we need to run it also as a module. So I'll run that here and see if it works. Whoa, it worked. So you can see the model was loaded successfully, and recommendation for Philadelphia story, we have it. So these are the different segments, that is each bullet that we have. So that is what this was doing. So each bullet, to make things clear. So we have the Philadelphia, we have the Pinocchio, the Fantasia, Rebecca, Toy Story, just the same output we had before. So that is exactly how it works. So our prediction is working perfectly. And now our model is ready. We have it in MLflow. We have it registered successfully. We're able to make prediction on it. Now we can move on to having an API that will consume this model so that the API can serve the model to a web application that we're going to be building in the last episode of this series. So in the next episode, you are going to be focusing on building the API, and we're going to be using Fast API for that. So thank you very much for following this tutorial. I believe you learned something. So if you have questions, you can put it in the comment section and I'll surely respond. And if you want me to do any follow-up video explaining some things clearly, I would love to hear that also, and I'll certainly do it so that it can help you learn better and enjoy this learning process on my YouTube channel. So thank you, and remember to subscribe to Learn with Meshach, like the video and share it so that people could benefit from it. So see you.